Hey everyone, how's it going? Thanks for joining today. My name is Drew Horn. I'm the Technical Director of Business Development at Sumo Logic. And Ian, go ahead and introduce yourself.
Yeah, so I'm Ian Buchanan, and I don't know, I guess everybody's engineers these days, so let's not focus on the title. I get to work with other companies like Sumo Logic and AWS and Slack for my role inside of Atlassian to help make sure that we have a full ecosystem to help make sure that our products fit and help make modern software teams work.
Great, thanks Ian. Okay, and today we're going to be talking about DevOps observability. So jumping into our first slide of the day, I thought, maybe we could just talk a little bit about Daft Punk just for maybe a minute or two. And I promise we won't extend this metaphor to the end of the webinar. What you're looking at here is fantastic music video for the Daft Punk song Harder, Better, Faster, Stronger. And I know that, a bit of a cliche to use the title of this song in talks like this, but after watching the music video, I couldn't help myself. The entire music video is actually a completely automated deployment pipeline. So in the spirit of end-to-end observability across the deployment pipeline and automation, I couldn't help but resist. So what we'll do is we'll walk through just some of the key expectations that DevOps engineers are kind of held to in today's modern deployment pipeline. So I wanted to talk a little bit about security. So, one of the expectations that engineers today have is that security must be built directly into the deployment pipeline, right? And so, that's not only application security, scanning dependencies, containers, et cetera, but also security of the pipeline itself, making sure that there's an audit trail in your pipeline, analyzing anomalies, things that shouldn't be necessarily happening in the pipeline, large check-ins of code in the middle of the night, et cetera. So this is one of the interesting challenges that DevOps engineers are held to today.
Yeah, and for better, this has been an interesting one that I've seen evolve over even a couple decades. So I think there used to be an expectation that the testing was this kind of even if slow and expensive operation at the end of development. It was kind of narrowly focused. It was usually very much about, does this software do the things that we said it would do as features? And it was also performed just kind of in that one narrow slot right before you send it off to your customers. But lately, things have really been getting much wider. I think with the influence of Agile, we see people embracing techniques like behavior-driven development or specification by example right up at the front when they're doing their planning. They're already starting to think about testing. Unit testing has become so pervasive that languages like Python and Go have brought unit testing frameworks right into the standard libraries. They're not something you have to go grab anymore. If we move into the domain of functional testing, that has been made a lot more automatable through tools like Selenium that have made it less brittle to create automated tests and keep them up to date over time. And then we even get into this sort of, what used to be just unthinkable idea of testing in production. And so that's the real range that we're dealing with now. But it's that last one that also starts to indicate the depth. It used to be this focus on functional testing because if you find any real architectural problems in that last test step, it's too late to fix them. You can't do anything about performance and reliability when you're just about to get the software out the door. And so I think that, between these two, the breadth and depth, we've seen some intense change, and not just because testing is like the thing we should do. It's the right thing. No, we have folks like Netflix or Etsy that have set a new bar that their levels of reliability have made all the rest of us look bad. We have to get to those levels because customers expect it.
Okay, moving on to faster, right? So, I think the expectation is, not only that you need to automate as much as, or in some cases, especially in SaaS, all of your continuous integration and deployment pipeline, but really, I feel like, that's kind of table stakes in a lot of cases, right? And the expectation is that teams need to be continuously collecting, near real-time feedback on the performance of their build and deploy pipelines, and continuously optimize and improve. So moving on to Stronger.
And Stronger is this one that kind of pulls these three together in a way that teams have to work closer together more than ever before in order to achieve these, and often in new ways. Bringing security into the software development pipeline, that's a hard thing to do, and it's also very new. Making sure the testing is kind of uh, more throughout the whole life cycle. That means bringing different people in and working with them in different ways. And the rest of the kinds of functions that get automated in the operations world, well, we don't ignore those either. And so now we have to bring operations system admins into this kind of more agile world, working quickly, not just responding to tickets anymore. So there are all kinds of new collaborations that bring teams together.
That's right, and we all can't be as good as Daft Punk. So let's take a look at some of the challenges that we have when trying to fully automate a software development and delivery pipeline. Taking a look at the pipeline itself, right? These are kind of the common DevOps life cycle phases that we all know and love. So everyone's kind of following the same high level framework here, but at the end of the day, the actual implementation of these pipelines are different, even at the same organization, right? So, each autonomous team, while maybe following the same framework, may be developing a completely different pipeline, resulting, in quite a bit of pipeline sprawl. And while that's good in that it allows teams to build things the way that help them, deliver code fast and reliably, the challenge it introduces is the inability for an organization to try to, again, going back to optimizing, right? It goes back to the challenge of teams not being able to get feedback at a higher level than just that individual team. So trying to understand your delivery performance, maybe by team or by product, or even at an entire organizational level, right? The other challenge here is that, when from ideation to production, right, those ideas, that source code, those artifacts, the deployments, right, are typically moving through quite a bit of different constituents across the pipeline. So going back to collaboration, right, it's really key for these teams to work together. And as things start to speed up, doing it as quickly as possible.
And this wouldn't be a presentation about DevOps if we didn't mention Conway's Law at least once. And so this is that time. This is the point at which, like, we shouldn't be surprised that the tools that grew up to support siloed organizations are themselves also siloed. So they're fragmented in terms of the kinds of data that they're used to managing. They're kind of sub-optimized for each of these kinds of functions. But then to complicate things, I think all of these tools are waking up to DevOps. We certainly are. And as we do so, these sort of vertically oriented tools are now kind of moving sideways. And as they do that, as they kind of become more aware of more of these aspects of the pipeline, they are also getting themselves more complicated. That means, like, this kind of integrating everything to everything. You get this web of complexity in terms of managing your tool chain that it didn't seem to be that bad before. So like, people are having a real reaction to this, but at the same time, there is a need for that. Just as Drew was explaining about the reasons why the people working need these different ways of working, well, the tools also need to reflect that. They need to realize that different people are at different points along a DevOps journey, or maybe even on different paths towards DevOps. And so it's important to realize that flexibility is necessary, but what can we do to help resolve it? So it's all really about the team. What can we do to help a team understand this whole picture?
One last challenge, the silent killer, Ian.
Yeah. So, and this really comes from that tool fragmentation that I was talking about, that what happens when you end up looking into, okay, how can we go faster, is you're going to see the top line. You're going to see that there are times that you're spending in certain phases along the way, and you're able to see that because the tools are telling you, hey, I know it took this long to make a commit, or I know it took this long to build. And okay, we look at this, we see these 480 minutes of semi-automated time spent in staging. And our habit would be to go, let's go focus all our automation efforts on that. We'll dial that down as quickly as possible. But what this misses, because of the fragmentation, is that there's actually time spent in between these stages. And then if you're trying to shorten the whole thing and you miss the fact that there's a handoff between test and staging, this is often where there are different teams, and the different teams bring their different sets of tools that aren't really working together well. Well, if you miss this, you're missing the biggest opportunities for improvement, which are often in automating the handoff, not just the work inside of one of these stages. So we wouldn't want to miss that there are 6 days spent between the staging team, because that's when they're waiting to pull things in or waiting for production to roll things out, because those are the places where we should be focusing our attention.
Yep, good point, Ian. And so I think to end the complaining that we've been doing for the past 5 minutes, just summarizing some of the challenges that we see here at Sumo, and Ian, I'm sure that you see as well over at Atlassian, is a lack of comprehensive visibility across the DevOps lifecycle. So individual teams, they know their tools, they know their processes, but when you want to start rolling that data up at a higher level, in order to make business decisions around how to improve the performance of your team, staff the team, or identify pervasive bottlenecks or challenges that multiple teams are having across the organization, or surface insights from teams that are really doing well, right? And allowing them, to share that information across the organization to improve, right? Challenge we see all the time: siloed and fragmented tools, not sharing data easily, lack of standardized data-driven metrics and insights. Very common, teams will implement, again, metrics to measure their individual performance of their autonomous team, super helpful. But, one of the pitfalls there is, if multiple different teams are building the same types of metrics, but, the algorithms or, the method and how they're computing those metrics are different, it can be really dangerous to roll those metrics up and start trying to compare across teams, right? And then limited collaboration, right? Just as a function of, tooling fragmentation, and pipelines that are kind of going through that maturity process, right? So, these are some of the key challenges that we've seen over at Sumo Logic, and in kind of in partnership with Atlassian, we've been working with them as a design partner on building out what we're calling software development observability. And this is a brand new solution at Sumo Logic, and it's a little bit different than kind of our traditional app ecosystem, right? We have 200 plus apps, right, in our app catalog that you can go in, install those apps, get a view of that particular the data associated with that particular tool and metrics that you can, or insights that you can derive from the data that you're pulling from that tool. With this solution, we're actually taking in data from all of your tools across the software development and delivery process, across the entire DevOps lifecycle. And the idea there is that we're building an integrated view of the CI/CD pipeline. We're deriving some of the industry standard DORA, or DevOps research and assessment metrics, that require correlation across multiple tools, right? To derive all 4 of those metrics, you can't just pull in data from GitHub or just from Jira or just from OpsGenie to do that, right? You really need to be pulling in data from multiple sources. And then, customization is really important for this solution as well. Everyone has different, tools in their DevOps tool chain, and having the ability to kind of plug and play your own tools in this solution and still maintain end-to-end observability across your DevOps lifecycle is one of the key requirements here. And again, the idea here, I think we all know the benefits, right, of being able to understand what's going across your pipeline at not just a team level, but at a product or or organizational or service level, right? The goal is faster release velocity, improved quality, reliability, security, and bringing these teams together. So one of the big focuses of the solution that I mentioned earlier is automatic computation of the DORA metrics, right? And why do we think that's important? Well, the research that the DORA team has done over the past 7 years has really kind of landed in this spot where they found that there are really 4 key metrics, 2 of them focused on throughput or market agility, and 2 of them focused on reliability. And the balance of optimizing these 4 different metrics really help teams deliver high quality code faster. And the surveys that they've been conducting over the past, I think 5, 6, 7 years now, as well as the applied data science they've put towards these results, have pretty much concluded that high performing elite teams have a significant advantage over others that aren't focusing on computing, benchmarking, and optimizing these metrics. So some of these numbers are a little silly, the advantage that elite teams have over lower performing teams, right? And the research has shown, right, that this data is a key predictor for quantitatively speaking, higher organizational productivity and profitability.
Yeah, and Drew, in addition to the kind of the numbers the street loves, there's this kind of softer side too that the State of DevOps report has been able to find correlation for, that it shows that these numbers actually correlate to improved team collaboration and culture as measured in things like a healthier work-life balance and reductions in burnout. They've measured this in terms of like NPS scores, like would you want somebody to come and work in your workplace? And this is just critical because I remember when I was organizing DevOps days back in Atlanta, we had John Willis come and talk to us about some of the things that he had been learning about stress in the operations world, and that sysadmins on certain psychological tests rank somewhere between firemen and policemen in terms of level of stress. It's just, it's unbelievable. And like, okay, it isn't that like, oh, we should just do this because sysadmins are stressed out. It's that we can't achieve the level of improvement that these high performing organizations achieve if you just put all of this stress on one part of the organization. So this is really about kind of spreading things throughout the team, helping make sure that you are performing together and collaborating. And so, yeah, this is the kind of data that we want to be able to see so that teams can build that kind of collaboration.
Yeah, great. Thanks, Ian. Yeah, so highly recommend everyone check out this report or prior reports, or even if you haven't, the book that has been written to back all of this called Accelerate. Definitely highly recommend at least reading the first few chapters of that before they kind of dig into all the meat and data science around how they pulled these results together. It's fascinating stuff. So taking kind of what we talked about at the start of the webinar and the DORA metrics, right? These are kind of, again, key focus for this solution. So I just want to talk briefly about how the product team here and how I kind of and some of our beta customers are thinking about this solution. The idea is we want to be able to come out of the gate with this solution and provide teams with real-time computation of these DORA metrics, right? But more importantly, as opposed to just kind of showing the numbers and showing some of the trend data, which is helpful, this entire solution is log-based. So we're collecting logs from and events from all of these tools, across the pipeline, or actually the entire SDLC, right? And we're taking that data and we're feeding it into the solution to allow teams to understand what is contributing to these metrics, basically providing observability, right? If I look at a metric, I want to be able to understand, what are the contributing factors? How can I drill down into these metrics and cut that data by the repositories or the teams or the services or the environments or the product, whatever dimension is helpful for me, so that I can uncover the issues or challenges or bottlenecks, and make an informed data-driven decision on where I want to focus my team's time to continue to improve. So that's kind of the high-level thought process. And then just a little bit more about the architecture. What I want to do after this is jump in and just show some of the dashboards to give everyone a sense of what data is available out of the box. But before I do that, real quick, I talked a little bit earlier about how all of these tools are feeding data into Sumo Logic. One thing, again, that kind of differentiates this from rolling this in-house or from some of the other solutions that you've seen out there, is that we've created a common scheme, a common unified schema for this particular solution, right? So we have the concept of builds and deployments and alerts and all of these different things that are part of this schema, this model. And as data leaves all of these particular DevOps tools and are fed into Sumo Logic, right? We parse and map that data to a single unified common schema. And that is what gives us the ability, that normalization process is what gives us the ability to correlate across all of these different tools. These are the out-of-the-box tools that we support, that we can automatically set up and configure both the tools themselves and the webhooks that they support, and the Sumo API, right? The whole thing can be configured and set up in just a few minutes via Terraform. But again, we allow teams to bring in their own tools. So if you're using GitLab maybe instead of GitHub or Bitbucket or Jenkins, right? You can plug in that tool, enable the webhooks, and modify the parsing and mapping process so that those tools are mapped to the schema. And then all of the dashboards, which are configured out of the box as well via Terraform, sit on top of that schema and run the appropriate computations to compute these metrics and the other insights with the solution. So it's just one of the important things here that are that's allowing us to extend this solution and continue to add support for additional tools from our broader ecosystem. And with that, let me pause the sharing for a moment, and I'm going to go ahead and bring up a couple of dashboards here. Just hopping over to, we're going for it. We're going for a live demo here. Okay. Ian, confirmation. Can you see my screen?
Yeah, we're looking good.
All right, great. Thanks. Okay, so just a couple of dashboards I wanted to go over here just to give everyone an idea of the solution. So what you're seeing right now is a live computation of the 4 DORA metrics, as well as some trend data. So we've got deployment frequency. That's how often are you deploying to production. Lead time for changes. This is the time it takes to go from a commit all the way to the completion of a production deployment. And pardon some of the demo data in here. Change failure rate is the percentage of changes made in production from a deployment that subsequently require remediation due to an actual perceived customer impact, right? And then time to restore services. How long, I think everyone's familiar with this, right? How long does it take to restore a customer facing impact, whether that's through temporary resolution of an issue in production, whether it's rolling back or rolling forward. How long does it take for the customer to get back to where they were, right? The breakdown of these boards, we have 2 high-level dashboards here. And then you're able to drill down into, we have some drill down dashboards as well. So there's a high level DORA metrics overview, which is what I'm showing now. And then we have drill downs for each of those metrics. And then we have just kind of cutting the data, looking at it a little bit differently. We have a pipeline overview dashboard, which I'm going to show, and then you'll be able to hop in. We have some drill down dashboards for the different stages, as well as pipeline stage monitoring. So
Drew, before you move
Yeah.
on, you had some colors on there. What are these? Green, yellow, red?
I just I just like to paint in my free time. It's what I like to do. And so, colors look pretty, no. Right, so thanks, Ian. These are the benchmarks. So we're automatically coloring these tiles based off of the benchmarking data from Dora. So there's a couple different levels. There's, I think elite, high, medium, and maybe low performing benchmark thresholds. And so we baked that logic directly into these dashboards here to give teams a quick understanding of where they stand. Yeah.
Cool.
Just an example drill down dashboard here for change failure rate. Again, what we're trying to do here, giving you a little bit more real estate in the dashboard and cutting this data by a few different ways for you to be able to start drilling down into things like, what's my change failure rate by service, by services or P1 incidents, what's my weekly comparison, this week versus last week. And then for the average change failure rate, what's the trend over the past, 7 days or 14 days. Moving into the pipeline overview. So this is a little bit of a different look at the data. Kind of thinking about the slide at the start that showed the pipeline. What we're showing here is the pipeline from right to left, kind of by criticality, right? So production alerts, maybe a little bit higher priority than a task you're working on, developing or a pull request you're going through, right? So there's kind of two panels associated with each of the areas, kind of a high level status, and then some tabular data that gives you some recent information that you may want to drill down into. So just maybe as an example here over on the right for deployments, we're showing, for the past 24 hours, what is the ratio between failed and successful deployments? And then some of the latest failed deploys, we provide links that allow you to drill down into the actual commits associated with those deployments, right? And so, there's some demo data here from our open source Sumo Logic Kubernetes collection. The idea here is we want to enable teams to jump in, take a look at maybe the commit data or the pull request, dig right into the code, maybe even look at a diff, see what changed, and just help kind of streamline that workflow process. So, you can hop into the dashboards, get a high level overview of what's happening, and then quickly hop out as needed, right, into your various tools to continue root cause analysis as needed. And so we have alerts, deploys, builds, pull requests, and issues. And a lot of our customers, right, there's obviously flexibility in what type of issues you want to send in here, right? You can send in bugs, you can send in work items, you can send in both, right? And so moving on. This is another view. This is the pipeline stage monitoring. This is one of the views that we added here in our beta in the past week or two. And what this is doing is this is giving you kind of a breakdown, almost like a trace. If you think of your pipeline as an application, and you kind of traced it as an application trace and looked at how much time is being spent in each stage for each pipeline. We're breaking that information down to try to provide teams, some visibility into the particular stages or pipelines that are contributing to a slower lead time here, so you can quickly understand what stages have been failing over the past 24 hours. Looking at each defined pipeline that you have. Right, we cut that, we stack that by the timings in each stage. So it's kind of obvious here that there's a stage that several of these jobs are using that are contributing quite a bit to the overall duration of pipeline execution, right? And then there's a couple, average stage duration, looking at the data a little bit differently, taking a look at the stages themselves without respect to the pipeline. Okay, and then again, we have filters up here at the top, right, so that you can kind of filter the data as needed. So if your team is only interested in particular pipelines, right, you can filter that data. So two more dashboards here. So these are drill downs from the pipeline overview. What we're showing here, this is the drill down for pull requests. So you can take a look, over the past 24 hours here by default, what are the created versus declined versus merged pull requests, looking at that data by the target branch, who are the top 10 reviewers by assigned pull requests that have been working on items, top 10 services by pull request. So that's kind of a services view of the data. And then we have some time series data here that kind of give you a sense of how much work is being created versus resolved. So if pull requests are kind of in a bit of a stalled out state, you'll have a nice visualization here that can show you that. And then some additional tabular data down here.
Yeah, Drew, actually, if you could pause on the top 10 PR lifetimes towards the bottom left. One of the reasons that I think this again ties back to the State of DevOps report, but they have really kind of pointed out that this is one of those places that is often the in-between. Like it's one of those things that is the 2-day instead of 480 minutes, because it's the place where the most human collaboration is involved, and it is a step that usually happens before a whole bunch of automation kicks off. So it's a developer has been working for some time, and then now it's time to get the code review going and have a look at that. The State of DevOps report found that it's really critical to keep that queue very small, that the time that you should be working on a branch, even in the world of Git, should be on the order of a day or two. So there's some benchmarks there that you could use to kind of drill down, understand why is this branch taking so long. There are cases where you really intend to take that long, and you're going to be working on a long branch. But the common case should be that you spend very short times on branches so that you avoid all of the headache of a merge conflict. That's why those merge conflicts are so painful, is because you accumulate so much change on a branch that it's hard to put it back together again. So this is really a kind of almost a purist view of continuous integration, but I think it's really critical that people start embracing this habit. So this is kind of one of those drill downs from, oh, those big numbers are great, but how are we going to get to deploying many times a day? Well, if you don't have a fast a development loop at the center of all of this, well, then all of the other loops get longer and longer too. So this is one really critical that it's to pay attention to, so that you get those bigger numbers
Yep.
tuned down.
Thanks, Ian. This data can be cut by different dimensions as well. So kind of we have here, based off of the data that's available by default, we can filter by status or repository. We've been working with some beta partners that are taking this a step further, and they're actually enriching the data that's leaving their CI/CD servers to allow them to get some different views, right? So, as a server is maybe, or GitHub is processing a pull request, right? You could emit information about, which team is this associated with, or which service or product, right? And if those fields are mapped again to our kind of common schema, you then have the ability to cut that data by those particular dimensions in here to give you some visibility into a different angle, a different look at pull requests. So the last dashboard here we'll go into, this is again another drill down. This is related to issues. So here at the top, again, we're cutting this data by default out of the box by a couple different ways: issues by type, by status, by the events that have occurred recently, by priority, and by project. And we can filter by all of those up here. So if you're aggregating this data across multiple different teams, again, you can provide team data and send that in and map it to our schema and start cutting by team as well. Or you can, filter and view the data by some of the fields available up here as well.
Yeah, and that's really critical, because we know, I know especially that Jira use is all over the board. There's so much variation. Everybody has their workflow and their sets of issue types and their custom fields to bring together. So it's fantastic that we have this common schema, this normalized model to map that information into, so that we can start to do comparison across teams and roll information up. But I think if there's one thing I'd like to draw attention to in this screen, it would be this, again, on the time, the longest to close. This is a place where you can drill down into a particular issue, start to understand what are the parts of your flow that are taking a long time, and especially where are things hanging out? What are the states that people are just letting issues wait in? And those are the ways that you really, again, kind of go up from the level of the dev loop, but then to a level of something like a sprint, or, if you're more Kanban style, just what's the overall unit of workflow, and you start to pay attention to to how it's flowing through your team as well.
Yep, and then kind of like the example before, right? We've been working with Atlassian to make sure that we're pulling in all of the link information for all of the issues. So again, our out of the box support for Bitbucket, for Jira, and for Ops Genie is going to include the ability, right, for especially in these tabular views, for you to quickly just kind of click in and continue, root cause analysis, go in and look at a particular issue, look at a particular pull request, look at a particular deployment. So,
Perfect.
okay, I think that's it on the dashboards. I think what I'll go ahead and do is pause here.
Yeah, thank you, Drew, and thank you, Ian. Great presentation so far. I want to say this is a great time for anybody that has any questions to post those in our Q&A function in the bottom right of your Zoom screen. We'll be able to answer some of those questions live for you and continue discussion there.
Great. Let me take a look here. So yeah, so one of the questions that that kind of comes up is around enrichment, right? So the question is, how can I enrich this data by teams? So that's actually, that's a common ask that we get, and we have from some of our beta customers. And there's a couple ways to do that. So for our out-of-the-box solution, we've included we have a Jenkins plugin, and we've since upgraded that plugin to supply an additional function that is available for you to enrich data, to enrich events that are being fired off from the CI/CD server, right? So for example, say in your pipeline, you have a unit test stage, right? And you're running a bunch of unit tests, maybe like as part of a build. We have a function that you can call, and you can provide some additional context to what team that may be related to. So you can put a team name in there, and when that stage completes and the data comes up to Sumo, that team information will be there. We'll map that to the common schema. And then you'll be able to kind of cut that data by team. There's other ways to kind of do this as well. We're actually dog fooding this solution internally at Sumo Logic as part of our kind of pipeline optimization initiative that we're running. And the DevOps team that we're working with there actually has created a map of their teams in the repositories themselves. So as part of the checkout process, our DevOps engineer runs a Groovy script that they have where they can go through, and based off of the service that's being built, right, they'll inject the appropriate team name into that function and send that up to Sumo Logic. There's some easier strategies as well for things that are a little bit maybe easier to map to, right? So on the source category, you can define some information there that's available to you. So if particular teams are tied to particular source categories at collection time, you can add some metadata there. And then finally, we actually have a new we have our new lookup tables that are available now. I think they're just right at the very end of beta, but it's all API driven, right? So one other additional strategy there is you could actually take, maybe your team mapping or service mapping or product area mappings, right? All of that classification that's unique to your organization, and pop it into a lookup table and even maintain sync with that through our API and the lookup tables. And then at that point, right, you can join that data as it comes into Sumo Logic. So. Let's see, any other questions? Ian, was there anything else? Anything else you wanted to cover?
No, I don't think so. Thanks, Drew.
Okay, Great. Well, hey, thanks a lot, everyone. Appreciate it. Thanks for joining, and have a great day.